All right, let's do some more practice with position, velocity, and acceleration. So the position of a particle is given by this equation where t is measured in seconds and s in meters. So find the velocity at time t. So we're just going to find our velocity function first, which is the first derivative of position. So we get 3t squared minus 12t plus 9. There we go. That's your velocity function at time t. It still has t's in it. What is the velocity at time t equals 2 and t equals 4? So I'm finding v of 2, so I'm just plugging a 2 in there, and then v of 4, so I'm just plugging a 4 in there. Let's see, 2 squared, 12 minus 24 is negative 12 plus 9, so negative 3 meters per second would be my units for that one. And then if I do 4, I get 9 meters per second. Whoops. Lovely. When is the particle at rest? Well, if your particle is at rest, then it means that your velocity equals 0. So then I'm going to set my velocity function equal to 0. And I'm going to pull out a GCF. So we'll get t squared minus 4t plus 3. And so then my factored form would be t minus 1, t minus 3. So my particle would be at rest at 1 and 3 seconds. When is the particle moving forward or to the right? We have to determine where the velocity of the particle is positive. So I'm going to take my velocity, or take my sign chart going on. I can't have time less than 0. And then I know my particle stopped at 1 and 3 seconds. So those are where it's at rest. So now I have to test values in between those. So 0.5, 2, and 4, and then I'll figure out whether my velocity is positive or negative at each of those values. And again, this is where it's helpful to be able to plug your numbers into your factored form, because I don't actually care what the values are, I just want to know if they're positive or negative. So here's my factored form. So if I plug in 0.5, this is always a positive, that would be a negative, that would be a negative. So 3 times a negative would be a positive number. V of 2, let's see, that would be a positive number, and a negative number. So a positive times a negative would be negative. And then V of 4, everything would be positive, right? Positive 3, positive, positive. So that means everything's positive. So we would say our particle is moving to the right between 0 and 1 seconds, and then between, or for time greater than 3, and then if you wanted to provide the explanation for it, which it is going to be helpful for you to get used to, we would say because v of t is positive. So that means that your displaced, or your direction of your particle is to the right or forward. All right, and now we'll talk about our distance. So displacement and distance are different. So distance is a quantity that refers to how much ground an object has covered during its motion. So distance does not take into consideration the direction, and absolute values are used to calculate total distance traveled because of this. So it doesn't matter whether or not my position of my particle is negative 4. It still means that my particle traveled 4 meters. So displacement, your displacement from your bed in the morning to your bed at night is 0, but your distance traveled could be like 40 miles depending on where you went. So what we're going to do is we're going to find the total distance traveled of our same object during the first 5 seconds. And so to take this into consideration, we have to know what our position function was originally. So t cubed minus 6t squared plus 9t. Yeah, okay. So we had to take into consideration too where our object came to rest. So it came to rest at it was, starting off at 0 seconds, 1 second, and then at 3 seconds. And then because they want to find the total distance traveled during the first 5 seconds, we can stop at 5 as well. So I'm going to find how far my particle moved from 0 seconds to, from 0 to 1 seconds. So I'll find that displacement, but I need to put absolute value symbols around it because I don't care whether it's negative or positive, it's still distance traveled. Then we'll do the same thing from 1 to 3 seconds. And then we'll do the same thing from 5 to 3 seconds. And we have to break it up like this because I know my particle changed directions at each of these times. So at 1 second and 3 seconds it did. And so I have to first find the distance that it traveled in that first section, then in the second section, and then in the third section. So let's see, S of 1 would end up being 1 minus 6 is negative 5 plus 9 would be a positive 4 minus 0. So that's okay because that was 4 meters. That's how far our object traveled from 0 to 1 second. And then our object from 3 to 1 seconds would be, let's see, if I plugged in 3 here, I think we already did that previously, but if I plugged in 3, we get 0. And then I found S of 1 previously as well was 4, so 4. Oops. And oh, I should probably put these around here. So even though, so my particle moved from 0 meters to 4 meters, and then my particle moved negative 4 meters, but in general, I still moved 4, right? That's what the absolute value pieces mean. And then again, from S of 5 minus S of 3, well, let's see, S of 3 we calculated was 0. Well, let's find S of 5, and that is 20. So that means my particle, or my object, moved 20 meters in the last section. So from 0 to 1 seconds, my particle moved 4 meters. From 1 to 3 seconds, my particle moved negative 3 meters, but it's still total moved, or excuse me, negative 4 meters, but still moved 4 meters, right? Don't care about which direction it was in. And then from 3 seconds to 5 seconds, our particle really sped up and moved 20 meters. So total distance traveled was 28 meters, and it didn't matter which direction that it was traveling in. So I added the 4 it moved in the first section, plus the 4 it moved in the second section, plus the 20 it moved in the third section. Doesn't matter which direction it was. All right, let's find our acceleration of our particle. So S of t was t cubed minus 6t squared. So V of t, if we recall, was 3t squared minus 12t plus 9. And then to find acceleration, I guess I should have written, that's okay. Acceleration, that's the first derivative of velocity. So I would get 6t minus 12, and it's finding it at time t, so my t's are still in there, and that's fine. Last but not least, when we talk about, this is the same example that we're working with, but when we talk about an object's speed, an object would be considered to be speeding up when its acceleration and velocity match in sign. So if your velocity and acceleration are both positive, that means that your particle is moving forward and it's accelerated in that direction. But it also works if they're both negative, because that means my particle would be moving backward and accelerating in the negative direction. An object would be considered slowing down when an object's acceleration and velocity don't match in sign. So that means that even though my particle is moving forward, like if my velocity was positive and my acceleration is negative, that means that my velocity is acting in this direction, but acceleration is acting in this direction. And so since they're acting against each other, that means your object would be slowing down. Similarly to how our rock, when we shot it up into the air, it had a positive velocity because it was moving up, but acceleration was acting on it because gravity was acting on it. And so our object slowed down until it reached the top. Okay, and so when you're asked to determine whether or not an object is speeding up or slowing down, you just have to compare its acceleration and velocity. So this is using that same example. We had our velocity function was 3t squared minus 6t, minus 12t, excuse me, plus 9, and then we found the acceleration in the last example part, and that was 6t minus 12. And so what we have to do is we have to figure out, compare essentially sign charts of when your velocity was positive and negative. We made a sign chart already for our velocity function. 0, 1, and 3 seconds was when our particle changed directions. And so our velocity had been, let's see if I can go back and find it. Our velocity had been positive and then negative and then positive. So positive, negative, and positive. And now we're going to do the same thing with acceleration and see what time intervals your acceleration matched or did not match your velocity function. The first thing I have to do, well, 0, obviously at time 0, but I have to figure out where else my acceleration equals 0 in order to find my breaking points. So I have to do 16 minus 12 equals 0. And so t equals 2. So I know that at 2, my acceleration equaled 0. So that means before and after it changed. So let's test our acceleration here. So if I test, I'll find a of 1, and then I'll find a of 3, and I'll test those here. A of 1, if I plugged 1 into my acceleration, would give me a negative number, and then a of 3 would give me a positive number. Okay, so now we're going to kind of compare these two things and what's happening here. All right, so from 0 to 1, my first dotted line, my velocity was positive, but my acceleration was negative. So that's going to go in the slowing down category. So I would say from 0 to 1 second, my particle was slowing down. And then from 1 to 2 seconds, my acceleration is still negative and my velocity is negative now. So that means that your particle or your object was speeding up. So from 1 to 2 seconds. From 2 to 3 seconds, my velocity is negative, but my acceleration is positive, and so I would say my object is slowing down. So from 2 to 3 seconds. And then from 3 onwards, both my velocity and acceleration are positive. So I would say for t greater than 3, my object is speeding up again. Basically, it's just a very finicky object. It's slowing down and speeding up all over the place. So that is it for some examples for velocity, position, and acceleration. We will work more with tables and graphs later. Right now we're just doing a lot of work with the functions themselves. So go ahead and go practice on those.